go through the last chapter of this subject, which is design patterns. So actually this chapter will not be included in your final exam, so it's just a general knowledge which is nice to know. Okay, all right, so let's continue. This is actually just definitions by Christopher Alexander. Okay, you can read yourself. Okay, a history about a design pattern. It started in 1994 when we call it GOF, which is Gang of Four, that involve Eric Gamma, Richard Helm, Ralph Johnson, and John Blisides. They published a book on software patterns. Okay, and then in this book, they primarily talk about the principle of object-oriented design. So let's understand where or how the design patterns involve in OOP. Okay, in general, normally in software engineering, a design pattern is actually a repeatable solution to a commonly occurring problem in software design. So as you learn from chapter 1 until chapter 10, we learn that how we can reuse the code by using those object-oriented concepts, right? Such as the classes, abstract class, interface, inheritance, etc. So it's actually a description or a template for how to solve a problem, right? When you design, it's give you a broad idea how you are going to solve the problem. For example, given a situation, given a case study, and then before you start with your code, you begin with the design patterns, right? And then a design pattern is not a finished design. So actually it's not a finalized part of the project. Okay, you cannot simply transform the design into code. Okay, you have to go through process such as you have to draw the UML diagrams, you have to know how many classes are going to be involved, right? And then the pattern actually records a successful solution in software development for sharing between projects. So when you have a pattern, so the general pattern, so it will be easier for you when you have to develop another project. Okay, when you are given, for example, when you are working in industry and then you already work on one project, and then after you finish, you will be given to lead another project, then it will be easier to use these patterns that you already did in project 1. So it's the concept of, like you mentioned here, the repeatable solution. So why we need design patterns? Okay, it's actually reusability. Okay, it's the reusability. Okay, it provides a head start. It gives you an idea on how can you tackle the problem. Okay, it also avoids error. Okay, that happened previously, you can avoid in future. And it's also, there's no need to reinvent the wheel. That means there's no need for you to go back and forth when you already have a complete, when you already, not a complete, but you have a rough idea about the project when you are doing the design patterns. Okay, it's also establish common terminology. Okay, that means design patterns provide a common point of reference during the development. So these are other advantages when you have design patterns, when you start with the design patterns before you begin with other steps in developing the project. Okay, most design patterns make software more modifiable, easy to change, robust, okay, by using well-tested solutions. Okay, when you use design patterns, it will also make the software system easier to change, which is easy to maintain. And it also helps to increase the understanding of basic-oriented design principles such as the encapsulation, inheritance, interface, and polymorphism that we already learned in the previous chapters. Okay, there are three types of patterns. Okay, there are creational patterns, structural patterns, and behavioral patterns. Okay, in creational patterns, it deals with initializing and configuring classes and objects. Okay, for structural patterns, it deals with decoupling interface and implementation of classes and objects, and it also composition of classes or objects. And then for behavioral patterns, it deals with dynamic interaction among societies of classes and objects. Okay, how they distribute the responsibilities for all those classes. So these are the components of the creational patterns. Okay, there are factory methods, there are abstract methods, builder, prototype, and singleton. So factory methods, we will go in details in the next slides by showing you the sample codes. So right now I'm just going to tell you the definition of the factory method. It's a method in derived class creates associations. Okay, and then the abstract methods is the factory for building the related objects, and then for builder is the factory for building complex object incrementally. Okay, and then prototypes, the factory for cloning new instances from a prototype, and singleton. Okay, singleton also one of the type of the creational patterns, which is a factory for a singular or sole instance. Okay, these are different types of creational patterns. And then for structural patterns, we have 7 types. Okay, the adapter, it translator adapts a server interface for a client. Bridge, the abstraction for binding one of many implementations. And composite, we have it's the structure for building recursive aggregation. And then we also have decorator that extends an object transparently. And then we have facade, it simplifies the interface for a subsystem. Flyweight, which many fine-grained objects that shared efficiently, and the proxy, that one object approximates another. Okay, and then for behavioral patterns, we have 8 of them, which is the chain of responsibility. Okay, chain of responsibility, actually it requests delegate to the responsible service provider. And then the command actually it requests first class object. And then iterator, it aggregates elements, access sequentially. We have interpreter, mediator, memento, observer, and state. Okay, state object whose the behavior depends on the state. Okay, so let's go through the factory method. Okay, so actually when we mention factory method, it's actually like the regular method that we already use in our previous chapters. It's just uh, in a different way to use it. Okay, so let's see the definition here. The definition it shows here. The factory design pattern is one of the most used design patterns in Java. Okay, it falls under the creational patterns, as these patterns provide one of the best way to create an object. Okay, so and then factory design pattern is used when we have superclass, which is the parent class, with multiple subclasses, which is the child class, and based on input. Okay, so we need to return one of the subclass. So this pattern take out the responsibility of instantiation of class from client program to the factory class. Alright, so when we have a superclass, okay, or an interface or abstract class that specifies all the that have the what we say, how to say this, that have the criteria as a parent, that delegates the creation details to subclasses. Okay, so factory methods makes the design looks more customizable. Okay, and only but a little bit more complicated. Okay, so we call factory because it creates various types of objects. Okay, for example, later on we will see the vehicle. We have different type of vehicle. Okay, so it creates various types of object without necessarily knowing what kind of object it creates or how to create it. Okay, let's see a sample of class diagram. So this is the class diagram for inheritance. Okay, in this class diagram, the superclass is the vehicle. Okay, we have interface vehicles that will the method to calculate the road tax. Alright, so the vehicles will be bicycle, SUV, and car. Okay, so when we do the implementation, okay, like the regular implementation, okay, we create the objects and then we print the road tax for each vehicles. Okay, but when you want to use the factory patterns, okay, you actually have two new elements in your UML diagram. First is the vehicle factory that will get the road tax value, and then vehicle test. Alright, so so when we are working with superclass in factory design, so the superclass in factory design can be an interface or abstract class. Okay, like we already learned in previous chapter. Okay, it can be either interface or it can be abstract class. Okay, so our factory design pattern example here, we show the example using interface superclass with the overridden method calculate road tax for testing purpose. Okay, so we have the interface here, public interface vehicle, and then the method public double calculate road tax. Okay, the concrete class or the subclass in the factory design design pattern, it works similar to the normal Java class that you already did. Okay, that you already been doing all this time. So actually, this class will override the superclass method and provide the implementation. I'm pretty sure that you are already familiar with this. Okay, so we have three types of vehicles here. We have bicycle, car, and SUV class that will complete the implementations for the calculate road tax method. Okay, so here we have the sample for our uh, situation here. So public class implement, public class bicycle implements vehicles, and then this one is for car, and then this one is SUV. We use implements, remember, because our superclass we use interface. So interface, there shouldn't be any implementation interface inside the interface class. So we implement inside the method. Okay. So in the factory class, we define a factory method that return the interface or superclass type. So to concrete implementations of the interface class. Okay, so the factory method defines an interface for creating object, which is the polymorphism based on input parameter, different subclass or concrete class in instantiate and returns. Okay, let's see the code sample here. So if we have a public class vehicle factory, okay, that means if you use vehicle factory, that means we are declaring the factory class. Okay, and then we have the factory method here, public vehicle get road tax. Okay, and then we have the interface object, vehicle object equal to null, and then the input parameter here, okay, the car, and then creating the new car object, okay, using the concept of polymorphism, and then we return the selected concrete object. Okay, so if the user choose car, it will return the road tax value for car, etc. If SUV, return the road tax value for SUV, and bicycle will return the road tax value for bicycle. Okay, created the main class of the factory design parents. So the main method is located and be the creator of the factory parents. So we declare the factory object from the factory class and use the factory method to get the object of concrete class that returns from the factory method by passing the input parameter. It also override method will display the expected output. Alright, so we declare the factory object, okay, inside the test factory, okay, as we have here in the class diagram for factory parent. We have vehicle test here, right? So we declare it, okay, public class test factory, okay, and then here we declare a factory object, okay, vehicle factory, factory obj equal to new vehicle factory, and then here vehicle object equal to factory object dot get road tax vehicle type. That means we get the concrete object from the factory method. Okay, we get it from the factory methods, and then we print the output from the override methods. It's kind of make the code a little bit more complicated than usually, but it will be useful in future if you have to keep reuse the code. Okay, so when to use design patterns? Okay, when we need to easily generate a different instance of object. For example, earlier we have to generate we have vehicle, but we don't care about what kind of vehicle we are going to generate. So it will be really useful, okay, when we need to generate different instances of objects depending on the environment we are in. Okay, we also it will also be very useful when we are working with many small objects or components that share the same properties. Okay, that will be very useful and it will save you a lot of time, especially when you are working in for a big project. So that's all for these chapters. Okay, so I already upload the lab 11 for this chapter. It's just an exercise. Okay, you don't have to submit the lab exercise. It's just a step-by-step tutorial for your general knowledge. Okay, if you do it, you get extra knowledge. If you don't do, you will not get it. Okay, it's up to you because you already university students. If you want to learn more, you can go ahead and do the exercise. Okay, so good luck with your hot tomorrow on Friday, January 15th, and thank you so much.